Hello everyone. In this video we will discuss about titrations which you may have already done in your lab or you will be doing in your lab, so this is kind of important. Okay, so what is the titrations? So titrations can be used to measure the concentration of acids or concentration of base, or you can do titration for a bunch of other applications, but the basic principles remains the same. So let's say you have some unknown acids right here. Oh, that was a bad picture. So let's say you have some unknown acid in their solution. So this is some unknown acid right here. Again, it doesn't have to be acid. You can find unknown base and flip the whole thing. So unknown acid. Okay, so you want to find the concentration of this unknown acids, right? So what you can do is you can neutralize the acid. So we know that acid plus base equals to what? Salt plus water. So this process is neutralizations, right? Neutralization reactions. So we have a lot of varieties of indicator that's gonna give a different color. Either the solution is, if the solution is acid, if the solution is base. So one such indicator is phenolphthalein. So that indicator is gonna be colorless when the solution is acidic, but it will turn pink when it becomes basic. So you want to find out the exact spot where it's turning pink. So how we do it is we have a burette. So this is a burette, and there is a stopper here, so you can control the stopper. So this is a burette, and what's in the burette? Inside the burette you have a base solutions with a known concentrations. So burette has marker. So what you're gonna do is you're gonna open this stopper here and let the base drip into the solutions here to the bottom, and you keep stirring the flask right here, Allenmeyer flask. And so what happened? You have acid here and you are dripping base from the top. So acid and base would be neutralizing, so they're gonna be keep making salt and water. So eventually you'll get to a point where all of your acids are being neutralized. Remember, everything must be balanced. So eventually you will reach to a point where all of these acids are neutralized. So that's the point called neutralization point. And at that point, you want to find out exactly how much volume of base you used. That can be pretty easily measured from just by looking at this number. So you know the base concentrations, you know the volume, you know the volume of this acid. So now all you have to do is do some basics math to find out the concentration of acid. So that's the problem we're gonna be doing. All right. So if you did not understand the concept of neutralizations, you can go watch the previous video, how acid react with base, and rewatch this thing again. Okay, so this is the problem that we're gonna try to do. So let's see what is happening here. So the question is asking, what is the molarity of HCl solutions if 18.5 milliliter of 0.2 to 5 molar sodium hydroxide solution is required to neutralize? So let's go back here, draw things out. So what was the concentrations of the base? So what base we are using? We are using sodium hydroxide base. What was the concentration of sodium hydroxide? 0.225 molar. Sodium hydroxide was 0.225 molar. How much we used? We use 18.5 milliliters. So volume, so you can, when you do the experiment, you can measure the volume. Volume was 18.5 milliliter. So the question is asking what is the concentrations, what is the molarity of the HCl solutions, and how much HCl we have? 0.100 liter. So in here we have a total of 0.010 liter. All right, so this is what we did here. Let me quickly recap. So you had 0.10 liter of HCl in the flask, and then you dripped some base into it. What was the base concentration? 0.225 molar. How much volume you used to neutralize it? 18.5 milliliters. Are we good? Okay, so when you're working with molarity, so what is the molarity? Molarity is, if you don't know how to calculate molarity, ask me. I'll send you the video from my previous courses. So molarity is, which is capital M, is N by V in liter. So what is N? N is number of moles, and V is volume. Make sure this volume is in liter. All right. So we are getting there. So because we want our volume in liter, so let's do this here. Convert this 18.5 milliliter into liter. All right. So it's 18.5 milliliter. So let's do a conversion factor. So we want our volume in liter. So let's put liter on top. You want to cancel out milliliter. So let's put milliliter on the bottom. So now milliliter will cancel out. And what is the conversion factor? Per each 1 liter, it is 1000 milliliter. So the answer is going to be 0.018 liter. All right, so this volume is in liter. That's good. The HCl is already in liter, so that's good. So I'm going to box this. These are the things we need. Okay, so once you have this, try to write a neutralization equations, right? So what is the neutralization equation is? So in this case, HCl reacting with sodium hydroxide, and it is giving you salt and water. So make sure the equation is balanced. So it seems like the equation is balanced. All right, so now which two component we are reacting? HCl is reacting with sodium hydroxide, right? So these two are the reacting with each other. So what is the molar coefficients? So the ratio is 1 to 1. So this is 1 mole to 1 mole. So make sure the equation is balanced. So make sure what's the ratio is 1 mole. So what does this mean? If I have X mole of HCl, it should react with same amount of mole of sodium hydroxide. X mole should react with X mole of sodium hydroxides. Okay, so we want to find out how many moles. So that's the mole to mole ratio. But what's given to us? We were given, I'm going to draw another box right below here. So you are given 0.225 moles per liter of 0.8 liters. Okay, so you are given 0.225 capital M, which is moles per liter of sodium hydroxide. How much volume? Of 0.018 liter. So first thing you want to do is find the number of moles. So that's the part A of the puzzle. Since we are starting from this side, I'm gonna put the arrow on the other side. Okay, this is how we're gonna go. So part A of the puzzle is find moles. All right. So what is the formula? Capital M equals to N by V. We know the M, we know the V, we can find the number of moles. So N gonna be capital M multiplied by V. So what is the capital M? 0.225. What is the volume? 0.018 liter. Make sure they are in liter. So the number that I got, let me do the math quickly. 0.225. Let's not worry about the sig fig for now. We focus on the concept. 0.018. Okay, I got 0.00405. 0.004 moles. Okay, so what is the conversion factor between sodium hydroxide and HCl? It's gonna be 1 to 1. So that means for every 1 mole of sodium hydroxide, it's gonna react with 1 mole of HCl. All right, so you have 0.004 moles, so you should get exactly same number of moles. Good. Okay, so now last part of the puzzle, so this is part B. Last part of the puzzle is convert this moles into volume, or sorry, concentrations, because we know the volume. What was the volume? Volume was 0.01 liter, right? That was the volume. 0.01. Yep, that was the volume. Okay, so in that scenario, what we need capital M. That's the things we need. So it is capital M equals to N by V. Must be in liter. Okay, what is N? N is number of moles. And what is the number of moles? Because we just found out that is 0.004. 004, which is moles. And what is the V in liter? That's given already in your questions, 0.01 liter. So the answer is, my calculator is saying 0.004 divided by 0.01. So that's going to be 0.4 moles per liter. So either you write moles per liter or you can write 0.4 m. Okay, that is the answer, 0.4 m. So you can draw a flow chart. So for example, if HCl concentrations and volume were given, then you go from here and then balance the equations, use the conversion factor, mole to mole ratio, look at the coefficient of the balanced equations. We got lucky here because we got 1 to 1, but you might find sometimes 1 to 2 or 2 to 1, and then you go other direction. So if you know the mole to mole ratio, you can connect any way you would like. All right, so that's all I had to say.